All right. Hello, everybody. Thanks for joining us today. My name is Harris Taylor with Diamondback Nozzles. Presenting today. Title of the presentation here is Continued Collaboration Across the Pond. This collaboration between E3D and Diamondback Nozzles. It was actually about a year ago. For the last Smurf that we launched and announced the Revo collaboration we had. Since then, we've got a year past, so we're excited to announce and share some new news there on some collaboration with the new products that we have. As mentioned here on the screen, is the Bamboo series printers, and we have others here in the slide that I'll be sharing with you. But before we dive into those, I wanted to share a little bit regarding how Diamondback nozzles are made. So the diamond making process, how PCB is manufactured. Also, there you see a couple of other bullet points. What are the benefits of diamond in FDM and 3D printing? And so why would you put a diamond in a nozzle? So a few of the key points we'll be going over. On the screen here, I've got a little animation. We'll get started. That'll step us through the process of from start to beginning of how we make diamond, starting from diamond powder. So we take single crystal diamonds in powder form and then convert it into the solid structure, which is PCD. So we'll start that animation here. So we take that powder, put it into a refractory metal can. So a little container, put some tungsten carbide. We needed some sort of metal in there, act as a catalyst. We oftentimes use tungsten carbide with cobalt, so cemented tungsten carbide. Put it into this assembly that you just see here on the screen. That outer cube acting as a gasket. So you got internal pressures inside of this press about 9 meters tall. So you have atmospheric pressure and internal that are over 1,000,000 psi. And so that gasketing material has to contain that energy, right? So not only are we adding pressure, we add high temperature to this, a graphite heater reaching over 1,400 degrees Celsius. So with those two conditions, and with the presence of that cobalt metal, that metal will liquefy, sweep into the diamond here, and that will be part of the animation here in just a moment, which gets us into a condition where the diamonds actually grow together. So you get diamond to diamond bonding. It's a little bit of confusion. Some people think we take this diamond powder, put it in a matrix or a glue, if you will. But it's rather the diamonds are growing together as one solid structure. So it's really where it stands out, where it gains its extreme material properties, vibration resistance, and the thermal properties that we often have. So as I mentioned during that animation, we reach over 1,000,000 psi conditions inside that press and over 1,400 degrees Celsius. And so when we come out of that press, or during that cycle of that press, those conditions it's like, what does 1,000,000 psi mean, right? For me, that's hard to even understand, like what's the number. So to bring it into reality here, we like to compare it to taking the Eiffel Tower and putting it on a surface area smaller than your build plate on your printer. Okay, the pressure that build plate would experience, and that still doesn't even bring it into reality. Maybe a little step closer to help us understand what the extreme conditions exist inside this process. It's probably a little more background on the company behind Diamondback. So Diamondback is the brand, and the company backing it is US Synthetic. It's a company based out of the US in the state of Utah, so that's in the western states of the United States. We have about 850 employees on site, a lot of engineers, a lot of patents being produced around diamond. We pride ourselves in being one of the leaders in diamond solutions in many industries, and additive manufacturing, 3D printing being one of those. We have about 80, over 80 of these presses on site on this campus that you can see on the screen, producing this diamond, three shifts a day, 5 days a week. So a lot of diamonds being produced there. I'm going to highlight just a few of these different products on the screen here. Primarily, we produce cutters for drilling, for oil and gas drilling, cutting edge, cutting teeth in those drill bits. Also, other applications are bearings. I'll go into here a little bit some of the material properties of PCD and why you would want to put diamond in a bearing. And so those bearings are used for really harsh applications, wastewater treatment plant, places where you don't want to have to go in, do any servicing, put them in hydrokinetic applications, underwater where it's generating power for small villages and you really don't want to have any downtime. So high reliability, long life. And this same diamond going into these products is the same diamond we're putting into the nozzles. Wanted to highlight our team back at US Synthetic that are making Diamondback nozzles. You know, we're really proud of our products, but I think we're even more proud of our people and the culture that we have at US Synthetic. So I wanted to highlight some of the team members here, Todd and Alex, you know, kind of similar key members there that are on the manufacturing floor, making these nozzles for us. So now we know how they're made. Why would I consider a diamond nozzle? Why would I want a Diamondback? What are the benefits it's going to provide me? Got another animation here to help us go over some of those features that we put into the Diamondback. So first is it's a solid piece of diamond. It's not a coating. It's not, like I said, a matrix, but rather these are diamond bonds. If you wear one of these nozzles out, I need you to give me a call, so I need to know what you did to it. That's kind of where we're at with this. Internal to the diamond, we have dual taper kind of geometry. Actually, it's kind of to help reduce clogging, keep that the extrusion force down. That paired with the material property of diamond, you can print some of the softer TPUs that would otherwise not be possible to just bind up in the driver gears. So you got the extremes of the soft TPUs to the carbon fiber filled, Kevlar filled, whatever abrasive materials you want to print, the metal fills. And so really just a great material for this specific application. And building upon that, so we touched on hardness already, but for those of you here who stop by our booth that we have, you can come experience the thermal conductivity. A diamond, a lot of people think it's more of an insulator, maybe in the ceramic realm, but it's actually the extreme opposite. It's one of the best thermal conductors out there, better than copper, better than silver, at conducting energy. So in one of these FDM type application, you think that tip of the nozzle is going to maintain a constant temperature, where other materials may have more tendency to vary and change over time as fans are blowing on it, as accelerations are happening, things like that. I mentioned we produce bearings. So the coefficient of friction of diamond is extremely low. These bearings actually have no lubricant, there's no grease, no oils, because of how low that coefficient of friction is. They're often placed in applications where there's water or some other cooling mechanism. There will be heat that will be generated, but there's no contained or sealed lubricant in those bearings, and that's due to the coefficient of friction. Translating that over into on the nozzle front, again, it goes to being able to extrude and produce with those softer TPUs, again, because of that lower extruding force that's required. So in many aspects, just these extreme material properties are really ideal for the application of 3D printing. I want to share, here's a video. We went down on a Friday and said, hey, let's go play around a little bit with some different nozzles that we have and run some tests. So there we have the accelerated wave test and all disclosure, and all videos are 2x at the time. So if you look there at the tip, you can go throw that on your printer and start printing. But there. So
I need to dust it off first.
that might be a good idea. So a little extreme, right? I mean, get a little pushback. I think, well, that's not how you use the nozzle, but I think it's just driving the point that, you know, if you're concerned about abrasion, that's one less thing you can worry about. Just worry about printing and producing the parts that you want to make and output on the printer. So we had fun with that. So now, what are the benefits? Talk about material properties. What are the benefits? Well, with Diamondbacks, you can unlock the potential of your printer, right? You can print The metals, the ceramics, not have to worry about the wear of the nozzle, wasting that filament. Swing by the booth. We've got some examples of 316 stainless steel that's printed on an FDM printer that you can come and check out. Those are kind of fun to see. But then we have print any filament, so it's not just these extreme metals, but you want to print PLA. You can swap and change. You just put the one nozzle in, and you then use your printer. Don't worry about changing out the hardware. Particularly with the bamboo nozzle and the collaboration we've had with E3D, just wanted to highlight that it is a drop-in replacement. We've worked with bamboo in testing and through E3D and their expertise in extrusion system and really tested this system, made sure it's a great product, ready to launch and make available. These same properties that I've been discussing about Diamondback nozzles apply not only just to the bamboo product line, but to all nozzles that we're making, whether it be the Revo, standard V6, or again, in this case, the new bamboo that was just launched. So it was about 2 weeks ago, we actually just announced that we have an extruder version as well. So Prusa just announced their 4X wide printer uses the extruder hot end. So we now have an option available for that, as well as the MK4 printer that they've had for some time now. We continue to work with other printing manufacturers. We have Rally producing a unicorn variant that will be coming up shortly as well. Really just using that collaboration to make sure we have products that are going to perform, interface with these different OEM printer manufacturers, and deliver a product that's going to help you get the most out of the printers you're using. We really appreciated E3D and the knowledge base they've brought. We brought some connections with some of these extreme filament manufacturers like Bassett, that's producing the metal embedded filaments. Like I said, if you get a chance to come sit by our booth and check out those parts, I think it might open up your ideas and the potential that simple FDM printer that you've got at home of what type of parts you can actually get and produce out of it. So we're really excited that we continue working with E3D, continue these collaborations, and continue to expand and bring Diamond and its capabilities that not many people are aware of. Continue to bring that into the industry of additive manufacturing. I appreciate your time and getting this overview of Diamondback, and we will kind of open it up to any questions if there's any in the audience.
With the video you showed, the very impressive extreme video, have you actually shown that to somebody and that isn't in the printing industry, and it's actually triggered them to say, we've got a use case for that? Because we're not the only industry.
Yeah, I mean, nozzles are used outside of additive. One of them being blasting, for example. So there's been some interest that have come in from that. Some silicon carbide, abrasive blasting. And so, yeah, so, I mean, everybody, I heard a little bit of giggling. That tends to be a common reaction when people watch that video of the wear test. It's just that surprise of, how robust that material is relative to, I mean, tungsten carbide is a great material. We work with it day in and day out at US Synthetic. But again, it's just a whole other level that the diamond properties that has.
Yeah, I wonder if there's anything technically or otherwise preventing you from creating kind of a holy grail three-way partnership with Bondtech and adding that geometry so you have something that is also high flow and also ultra abrasive, or does that not make sense because the high flow insert or whatever would deteriorate over time?
Great question. Yeah, high flow is definitely a hot topic right now. It's definitely something that we're looking at and seeing how we can integrate diamond into that, and if it's enough benefit for that. I mean, diamond's wonderful. I talked to you about all the great properties of diamond, but not some great properties of the cost. So is that cost benefit there for high flow type application? Something that we're definitely considering.
And does it make sense because by definition with the diamond, you're going to print something that's probably got a lot of fiber in it or other additives that are probably not going to flow that well anyway.
Yeah. Yes.
So when you said that the coefficient of friction is really low, particularly if you've got some liquids and hydrogen involved, does that mean you could possibly make something like a linear rail that is pushing on the diamond surface to make it even slippy up?
Yeah, sure. Like I said, we have a whole sister company, sub company that they focus primarily on bearings and bearing surfaces. Again, it just comes back to cost. Is the cost there to be putting diamond into that specific application? You can run dry bearings, but again, typically there's some sort of coolant, some mechanism to get the heat that is generated from the slipping out of there. And so just running a dry bearing, we'd have to look at that and see what all that. Yeah.
So what's the longest part you could make out of this diamond material?
The longest?
Yeah,
You mean geometrically, how big of a piece of diamond? Like,
yeah,
well, to get those extreme pressures and conditions, we really have to condense it down. So think about probably about a 25 millimeter diameter by 25 millimeter height is kind of the rough size. Yeah, so the bearings that I mentioned typically take an array of diamond, like a circular array. It's not one solid piece. So, these bearings can be in various sizes, but it's just an array of diamond.
So I get this is gonna be proprietary in terms of how you actually work the diamond, but are there any like specific geometry constraints as to what you can make out of it? I feel like CHT nozzles is one example where the geometry is complicated. Like with the inserts method that E3D is presented on the Rico high flow, that potentially goes away. But like if you wanted to make a more complex geometry, like how does that work?
Yeah, that's a wonderful question. The parallel that we like to use oftentimes with machining diamond would be like asking somebody to build a wood table and having them a 2x4 to do all of the cutting into a piece of lumber to cut a piece of lumber, right? We use a lot of diamond to grind and process it. We use laser technology, we use PDM technology, we use a wide variety of technology to process this material. And we're always looking to expand our capabilities. So these geometries you asked about are definitely in the realm of possibility. Really just boils down to cost benefit of being able to produce it, and does it move the lever enough that, hey, this is worth making and putting into a printer. Yes.
I think when most of people hear diamond and nozzle, they probably only think of the abrasion resistance as the first thing.
Yeah.
But is there anything that you see that you open up a use case for because of the low friction and the high thermal conductivity that most people might not think about?
Yeah, I kind of touched on it just a little bit during the presentation. Was eventually customers come back and say, "Hey, I want to let you know I wasn't able to print this TPU before, but now I can." And it was surprising to us, right, receiving that feedback. But as you look at the data of it, it makes sense, right? That extrusion force that's required prevents it from binding up in the extruder gears, and so you can actually extrude the soft TPUs and produce a usable part. Or otherwise you just say standard brass nozzle, it just doesn't function, it doesn't extrude. Thank you. Thank you.